Hello learners, today we are going to perform the process of docking by using web server. In this process, we know that docking is a process which is an in silico process where we use a ligand as well as a protein and they interact with each other with the help of machine, which is computer software which we use. So, and then once the process has been conducted, we will get the result, which is the outcome of the molecular docking. We visualize the docking, we calculate the energy which has been given by this particular machine, and then we do the process of virtual experiment. So, if we look for the steps which are required for molecular docking, then these are the steps where first process is the preparation of the protein and binding site analysis, ligand preparation, docking, and scoring function, and validation of the docking protocol. So, without a further ado, I'm going to show you the process of docking with the help of a web server. And why we are going to do it? Because it doesn't need much space in your machine. It can be easily done with the help of cloud-based web server. And you can even see the doc poses with this particular web server only. You don't have to go for some other visualizing software to see, okay, like what is the pose, the best pose of the docking is. I'm not going to talk too much theory about the docking because there are videos available by different creators. I'm only going to show you the demonstration of docking. So here I'm going to just to show you how can we collect protein structure. So you only have to search PDB database and you will find this home page where you can click on this website and you can find this a protein database where you can find many protein that you can use in the docking process. One of them which I'm going to use is OZRY. This is the protein, which is a creatine protein, and I wanted to use it for my docking process. You can see its crystal structure. It is an intermediate filament protein creatine 1 and creatine 10. It is always see that this protein belongs to which organism. So it is like Homo sapiens. You can even see the method which is used to get this structure. It is X-ray diffraction and the resolution of the protein that is 3.30 angstrom. You can download this structure by clicking on this particular tab and download the legacy PDB format. Don't go for any other format because this is the format which is majorly used in the docking process. Once you click on this particular thing, protein structure will be automatically downloaded in your machine. Now, the other thing which we need is the, what do we call it, ligand. And in this particular case, let's suppose as I want to dock my protein with the camphor. So I'm going to use this particular website pubchem.com and you have to simply type the name of the ligand camphor. Now you can see it has appeared. Click on the particular compound and you will find various information about the ligand. I need the smile format of the ligand, which I'm going to use it for my docking process. Now let's see the web server where we can perform the docking. I have recently finished a docking process. Now, for you, I'm going to demonstrate it again. So, what do I have to do here? I only have to open this web server, and then click on enter. This is the page which you will observe first. Now, as we have to use Legion, and it supports the Mol2 file format and the Smile format, which we have just copied. I'm clicking on the paste button and my Legion has been pasted in this particular site. Now, click on prepare Legion. The Legion will be prepared in a fraction of second, and it will take only few seconds to for the preparation of this particular Legion. Now, here you can see that as the ligand is dropped with the protein, we have to provide either the PDB ID or if you have the downloaded file, you can choose the file. Go for the place on your desktop where the folder is there. Click on the PDB ID and open it. It will be uploaded. Now you have to prepare the target also. Prepare the target. Now in the docking process, if you have seen that we have to use different coordinates of the protein where you want that docking of the ligand can be done. So these are the different center boxes, like as you can see here in this particular visualizing panel that box has been created. This is the default setting of this website. If you have the information about particular grid box, you can enter it by going through the literature survey. Like I do have the information about it, so I am actually you know uh, shifting it as I have to set the grid inside this specific protein. So as you can see, I'm clicking on different x, y, and z coordinates, and the size of the box is changing. These are the coordinates which actually I have to set for my docking process. Now you have to select the parameter, check the parameters that you have checked for the the, the protein, target protein, as well as the ligand. Will again take fraction of second to check it, and then again we are going to proceed with other options. So if you want to get notified your docking has been done, you can give your email ID and they are like as I'm doing the docking with the camphor, I'm using cam and it is with the cam 4 because 4Z RY is my protein ID. So it is just to remind me that what complex I have received from this particular web server. Now click on start docking. As you click on it, you will see the parameters you have given for this particular process. So you can see that date is 24 where I submitted this particular job. Now the name is camphor, which I have given for a couple of seconds. The ligand is a camphor, as you can see the smile notation of it. The target protein is 4ZRY. These are the coordinate which I have set for my grid box. Now you can see that exhaustive sampling technique has been used for these civil docking. And this is the estimated time for the job, which is actually needed for this web server to execute the process of docking. Now, as the process is going on, I also want to tell you one more thing that you can click on this link so that you can further, retrieve your result if you are busy somewhere and you don't have time to sit continuously in front of your machine and check the progress. So you can bookmark this link also. And previously, I'm showing you like you can even go for, get the notification in the previous page when docking is done. So that can also be done. Now you can see here that the docking process is completed. And while, showing the features of the website only, it has finished it. So it did not take much time. It was hardly few seconds to a minute in which the process has been completed. Now, what are the things you have to observe here is the first is the ligand which you have given the PDB ID. The method is the use is retractive cavity. This job was given on 24th April. These are the box center coordinates and box size coordinates. If you want to use this result in your research publication, you have to use these reference. Then now you can see the visualizer which is actually there with this web server. So most of the time, if we are doing docking in other machines, we cannot see what is happening. But here you can easily see and observe that what kind of cluster is there, how the docking is being done. And at the bottom, you will find the energies of the different poses of the ligand and protein. These are the different scores which has been generated by this web server. Yeah, if you want to see, like, as in this web server, first score is the best score for docking process. You only have to click on this first score. Let me show you, like, once you click on this score, you will see change in the visualizing panel. So here you can see the ligand camphor, which is docked with this particular protein. So here you can see that these are the hydrogen bonds. Is there these lines which are there? It indicate the hydrogen bond. Let's see here also, here also, here also I can find. If you want to see hydrophobic context, then click on the hydrophobic tab. See, these gray line have appeared. So these are actually hydrophobic contexts. If you want to see the protein surface rather than these loops and all, we click on show protein surface. Such a wonderful visualization you can observe now, which is actually a publication image of the docking. Now, how can you access or use this image for your research work? You only have to use a tool SNP, SNIP, SNP. It is there with most of the system. So you only have to open the SNP and click on new, copy the part of the visualizing panel which you want to use and save it in PNG format. So whenever like you want to use, you can use this PNG image for your publication. So this is all about you know uh, docking with the help of SwissDoc, which is really available web server. In this particular demonstration is for the beginners who are interested to learn this particular in silico technique for their research work. So, again, thank you very much.